All right, this is our last lecture from chapter 12. This is on synthetic polymers. So the last lecture ended talking about natural polymers, the macromolecules like nucleic acids, proteins, carbohydrates. Now we're talking about man-made polymers. So the common name for man-made polymers is plastics. And you are very familiar with these because you really can't go anywhere in today's world without running into a synthetic polymer. The thing is, these are widely popular because they have such a wide variety of uses. They have replaced so many materials because they are generally less expensive, and in some instances, they are actually more durable. They are actually now used more than steel in the United States. So they are actually very, very popular. So let's talk about the different types of synthetic polymers. So the first group are the thermoset polymers. These are the first synthetic polymers that were created, and actually a lot of these are still around today, the ones that were created at that time. So the thing is with thermoset polymers, and you can actually get kits to make thermoset polymers, the polymer chains, so the long chains of the monomers, become interlocked into a rigid 3D network. So thermoset polymers are not flexible. They are going to be a hard type of plastic. In fact, a lot of the thermoset polymers, many people don't even realize that they are plastic because of this rigid nature that they have. They are incredibly strong, incredibly durable polymers. Like I said, pretty much all of these are still around today because once they are formed, they can't be remelted or reshaped. Basically, all that we can do to them is break them into tiny pieces. So we can't actually reuse any of these insofar as reusing the polymers, unlike some of the polymers that we make today, as we'll see in some of the later ones that we're going to look at. We can reuse some of those. So examples of these, some of these names may sound familiar. So Melmac, that one was commonly used to make different types of dishes. Formica, that one's actually still sometimes used today to make countertops. And then Bakelite. Bakelite was used very often to make different things like radios, telephones, things like that. So you may have seen some of these around. So this is the original Bakelite phone. You can still pick one of these up in some places today. This is a Bakelite radio. The one thing that thermoset polymers are still used today to make are pool balls. And this is, again, because of the nature of this material. It's incredibly durable, incredibly tough, and since pool balls undergo so much abuse, it's an incredibly useful material for that use. Most people don't realize before thermoset polymers, most pool balls were either made out of wood or most commonly they were made out of ivory. That's right, elephant ivory. And so this actually saved a lot of elephants from being slaughtered because of their ivory for their tusks. And pretty much all pool balls that you're going to come across today, unless they're a very, very old set, are going to be made out of this thermoset polymer. So our next type of polymer, synthetic polymer, is polyethylene. This may sound familiar from an earlier lecture. Ethylene is one of those materials that we talked about early on. Poly for multiple. So there are actually two types of polyethylene, but it depends on how they're put together. When the strands are actually put together, and they'll be put together into two different configurations using catalysts. So you can see over here, there are pictures of how these strands will get laid out. So the strands will either get laid out in long kind of spaghetti strands that don't really overlap or branch. or they can get put together into a branching formation where the strands are actually stuck together. And this actually changes the nature of the polymer, of the polyethylene polymer. You are actually familiar with these two types of polyethylene. One is called HDPE, high density polyethylene. This is the first one with the strands all stretched out and not branched or connected. High density polyethylene is going to be a very rigid and tough polyethylene, and if you drop it into boiling water, it will hold its shape. It won't deform or malform. It will stay in that shape. And this is what we use to make milk jugs and bottle caps. So if you want, you can try it as an experiment. If you've got a milk jug around, you can actually either take the whole jug or part of the jug and drop it in some boiling water, and it won't change shape. This is really helpful because this allows things like disinfection to be done, and it won't harm the plastic. It won't melt holes into it. The other type of polyethylene is LDPE, low density polyethylene. And if you look on some of the containers that these are made out of, you may actually see these letters stamped on them. It's usually around the recycle symbol that you'll see these letters. LDPE is a flexible, bendable polyethylene, and it's because of these branches. The branches leave more space in between the polymer strands, and so that makes it more flexible as a material. It does deform in boiling water, so this is not something you can use in a hot type of situation because it will melt, it will get holes burned into it, things like that. And this polyethylene we use for things like plastic wrap. Ziploc bags are made out of LDPE, and trash bags. So this is why you can't, for example, put food in a Ziploc bag and then put it into boiling water because that bag is going to melt. Okay. The next polymer that you've run into in your daily life is polyvinyl chloride. So if you look down here at the bottom, you can see the monomer, and you might be able to get an idea of why it's called polyvinyl chloride. So you've got chlorine as one of the molecules that's in the monomer. And the interesting thing about polyvinyl chloride is depending on how it's put together, it can either be made into a rigid material or a flexible material. So you may have seen polyvinyl chloride listed as PVC. So the most common thing that people know PVC for is pipes. But it's not just used in pipes. So you can use it in pipes. You may have it around the doors and windows in your house if those are made out of plastic material. But we can also make polyvinyl chloride into bottles, bank cards. So most of your bank and ATM cards or ID cards in your wallet are actually made out of polyvinyl chloride. That's why they're not recyclable, because this is a really tough material to recycle. But also we make insulation and imitation leather out of polyvinyl chloride. So if you have vegan leather, it's actually made out of polyvinyl chloride, as well as you can see in the picture here, shower curtains. So it's a very versatile type of polymer. Another one that I know you've all seen and used is polystyrene. So poly again for the polymer and styrene for the monomer. You might be catching on to how we name these polymers. So here are the styrene monomers, and it's got a benzene ring in it. So when we join them together, we get our polystyrene molecule. What's interesting is what we can do with polystyrene. So polystyrene can be made into these types of clear kinds of plastic, these kind of transparent plastic cups and household items. However, if you take and blow gas into the liquid form of polystyrene, this is how you get styrofoam. So all three of these glasses are actually made out of polystyrene polymer, but the difference is the blowing the gas into it while it's forming gets you this poofy styrofoam. Now the thing is like polyvinyl chloride, polystyrene is also not recyclable. It has to do with how we take these apart. They do not stay stable as far as being able to recycle these molecules. So we can't take styrofoam and recycle it and make it into new styrofoam, or take these plastic cups and recycle them into new plastic cups. The last of the polymers that I wanted to show you of the synthetic polymers, and this is only a very, very small fraction of the synthetic polymers that we use and make, is this one, which is polytetrafluorothylene. Yes, say that 10 times real fast. So polytetrafluorothylene is actually got a brand name. This is Teflon. So Teflon is actually a really interesting polymer because of how it's constructed. It creates a non-stick surface on things like pans because of one atom that's in this polymer. So you can see it's got a carbon backbone in the monomers, but on either side it's got fluorine. And fluorine atoms, when they're in these monomers, tend not to be attracted to other molecules. They're very, very happy in their arrangement with their carbon atom buddies, if you want to think of them that way. And so since they are really, really happy and stable in that arrangement, they're not going to be attracted to try and stick or bond with anything else. And this is what creates that non-stick surface in a lot of non-stick pans that have Teflon on their surface. The other thing is, because that carbon fluorine bond is very, very strong, this is what allows us to use nonstick pans at pretty high heat. So that bond is not going to come undone when we add heat to those pans. All right, that is the end of chapter 12 with organic chemistry. There's one last chapter for this course, which is on nuclear reactions. So I'll pick up there with our next lecture.